This is Geometry, Unit 6.4a, Coordinate Proofs. Now these proofs are not like the proofs that we did during first semester. These proofs are just using the midpoint, the distance, and the slope formula. We don't have a 2 columns, we don't have if-then statements. We just have to prove what we're trying to show using these 3 formulas. So these proofs should be much more reasonable and not as scary as our geometry proofs we've seen before. A coordinate proof involves placing geometric figures in a coordinate plane. That's what we did yesterday. We put them in standard position. We will assign convenient coordinates to the vertices, and we'll use the midpoint, the distance, and the slope formula to generate the proof. When you use variables, listen to this carefully, when you use variables to represent the coordinates of a figure in a coordinate proof, the results are true for all figures of that type. So if we're working with a square, kind of like this one down here, and we use letters rather than numbers, and we show that the diagonals are perpendicular to each other, that's going to be true for any set of numbers that you replace with the A. All right, the first thing we're going to do is find the midpoint and the length of our segment AB. Here's A and B. Now, yes, I see that these are with letters, but these are still graphable. We can put them on a graph. We were doing that some yesterday. A is located at 0, H. So 0 means right and left. H is up some distance. It doesn't really matter how far up you go. It's just up some distance. So that would be 0, H. Then we're going to plot point B. That's at 2G. Well, we don't really know even where 1G is. Okay, so we'll pretend like 1G's here. So 2G's going to be out farther. And then if 1H is up even with the A, 2H is going to be up twice that much. So it just gives you an idea of what this segment would look like. So now we're going to take these coordinates and we're going to find the midpoint, then we're going to find the length using these coordinates. This would be considered our x2 and our y2. This would be our x1 and our y1. So if we're going to find the slope, the midpoint first, we're going to use our midpoint formula. There's our midpoint formula. This is the only one, notice, where you add the 2 x's. In distance, you subtract the 2 x's, and in slope, you subtract the 2 x's. And we're going to add the 2 y's. The other 2, you subtract the y's. This is the one that's a little unique. So we're going to add our x's. So x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Notice that midpoint has a comma in it. Some people in a previous quiz were using this comma notation for answers for distance or slope. You need to understand what the notation stands for. This is a spot or a distance. Well, let me rephrase that. That's completely wrong. This is a location, not a distance. Right? This is an x comma y answer. So we have 2g over 2, and this is h plus 2h. So 1 plus 2. This is 3h over 2. Well, we can reduce one of these. We have 2g over 2. So you can reduce the 2's out of that and call that g. But here we have 3h divided by 2. 2 doesn't go into 3 evenly, so we're just going to leave it. 3h over 2. That would be your midpoint. Let's see if that makes sense here. If we're looking for the midpoint, and that would be right here, m, that would be the halfway. It's going to be between 0 and 2g. The x value is going to be between 0 and 2g, so that's going to be at g, 1g. That's how far over you'd have to come. If 2g was a whole distance, 1g is going to be half that distance. And then between 1h and 2h is the 1.5h, 1.5h. That's what this represents. 3 over 2 is 1.5. So that midpoint should make sense. Now let's find distance. What is the distance between A and B? So using our distance formula, we subtract the x's and square it, plus we add or subtract the y's and square it. So 2g minus 0 squared plus 2h minus h squared. So think about what this means. Don't wait for me to write it down. You can think about what this means. What is 2g minus nothing? That's still just 2g. And we still have parentheses, and we still have a square. Plus, we have 2h minus h. So this is kind of like 2 hippos minus 1 hippo. That gives us 1 hippo, 1h. The h's don't disappear and you're left with a 2. It's 2 h's minus 1h leaves us with 1h. Now we're going to square. So the parentheses are important here because that tells you you're going to square the inside also. This is 2g times itself. 2g times 2g. That's going to give us 4g squared. You've got to have the square on the g. You've already squared the 2. Now you're squaring the g. Plus h squared. We cannot simplify this. We cannot simplify this. Yes, you can take the square root of several different pieces in here, but because it's plus, because this is a binomial, you can't really apply the square root symbol to it. So that's your answer. Makes life a little bit easier. If there was no plus, then you could start taking the square root of things. But because there's a plus, we can't get to it. Or a minus. If there were parentheses, that's a different story. The plus is inside parentheses, that's a different story. But that's not what we have. All right, find the length of a diagonal of this square. Well, we're going to first find this diagonal here. Remember, a diagonal connects two non-adjacent vertices together. So, the length, which is a distance formula, says to take the x value. I'll start with the larger one. All right? So we'll call this one our x2, and this would be our x1, but then that makes this your y2, and this would be your y1. So we'll say a minus 0 squared plus 0 minus a squared. That gives us a being squared, and that gives us negative a being squared. 0 minus a leaves us with this minus a. The 0 is irrelevant. I can square the a, and that's pretty obvious. Now, in parentheses, I'm squaring the negative. So what do I get when I have negative times the negative? That has to be a positive. And a times a is a squared. So here I have a squared plus a squared. That's 1a squared plus 1a squared gives me 2a squared. Here we don't have any pluses. This is called a monomial. We don't have different parts adding and subtracting. So, can you take the square root of 2? Well, that's a decimal. We're not going to do that. So, no, we don't take the square root of 2. Can you take the square root of a squared? Do you know what times what makes a squared? A times a makes a squared. So, the square root of a squared is a. A times a makes a squared. So that's what the square root's asking. What times what makes a squared? A does. And the 2 is left inside the radical, because we couldn't take the square root of that. So that is our diagonal length. What do you suspect is going to happen with our other diagonal length? Is that going to be the same? Is that going to be different? Same. Any rectangle shape is going to have congruent diagonals. A square is a type of rectangle. It has right angles. We have to figure out this coordinate. So what's this coordinate going to be? Everyone think about that. How far over do we go? A. How far up do we go? A. So this has to be a comma a. Now we can do our distance formula again. So we do our x minus our x squared plus our y minus our y squared. A minus 0 is just a, and that's being squared. A minus 0 is just a, and that's being squared. So square the a, and I get a squared. Square the a, and I get a squared. So that gives me 2a squareds. How can I simplify 2a squared? Because I can take the square root of a squared, that becomes a. What do I do with the square root of 2? We just leave the square root of 2 as it is, because it's not a square root of 4. It's not the square root of 9. It's just the square root of 2. I don't know what number times what number makes the square root of 2. So we just leave it in that form. We don't want to use calculators. So there we have it. Our two diagonals are the same. So if our distance is the same, they are congruent. Equal in length will show congruence. Find the length of each of them. We have shown that the diagonals are congruent. That's going to be true about every square, because we did that with variables with a square. Now we're going to use this quadrilateral with these coordinates, and we're going to prove that these opposite sides are congruent to each other. So we're going to do distance formula again. So the distance formula for Wx, so we like to label our work, Wx equals the x value, 2a. What coordinates down here at W? This is 0, 0. So 2a minus 0 squared plus 2b minus 0 squared. That leaves me with 2a squared plus 2b squared. How can I work with that? What can I do? How do I square 2a? 4a squared. And how do I square 2b? 2b squared. 4b squared. Now, before we talked about how you could take the square root of 4a squared. But now this has a plus. We can't take the square root of that. We're stuck. Or even better than stuck, we're done. We've gone as far as we can. That's the good part about using variables. When you can't simplify it, you're just done. It actually makes it easier. So that's our length. Now we're going to compare that length with zy. So zy says that we're going out a distance of 2c plus 2a, or 2a plus 2c. That's the total distance we're going. And we're going up a height of 2b. We're going to figure out this yz. So we do our x minus our x. So that's 2a plus 2c minus 2c. Notice what I did there. You always want to start with your double letter when possible. This has two parts to it. So don't say 2c minus the double letter. Start with the double letter part and say 2a plus 2c, and then subtract your x1. Plus 2b minus 0, quantity squared, what am I going to get here? 2a plus 2c minus 2c. What does that give me? That gives you the 2a quantity squared. The two c's cross off because one's positive, one's negative. 2 cats minus 2 cats is no cats. No c's. 2b minus 0 is just the 2b and it's squared. I cannot take the square root of the squares. Can't do that. But you can use those squares with the parentheses. That's 4a squared and 4b squared. So look what we have. They're the same. The distances are the same. They are congruent. You proved, using your distance formula, that the opposite sides, the WX and the YZ, were congruent to each other by showing that their simplified form was the same. How are we going to show parallel? What does it take to show parallel? To show two segments are parallel, show slopes are equal. To show the segments are parallel, we have to show the slopes are equal. So we're going to use the slope formula. We're going to do the slope of WX. Y2, so we're going to take the Y value. Here's WX. We're going to take the Y value, 2b minus the Y value, the X value minus the X value. 2b over 2a. Can you simplify that at all? We've got 2 bananas and we've got 2 apples. We can reduce the 2's out of it. So we're just left with b over a. That is our slope. Now we're going to look at the slope of YZ. ZY. To do that, remember, here's your Y, here's your Z, so it's going to be 2A plus 2Y minus 2C. This is your Y, oh, I actually said that wrong. I apologize. These are your X's, aren't they? X2, Y2, X1, Y1. We have to do our Y's first. So we're going to say 2b minus 0. 2b minus 0. Then we're going to say 2a plus 2c minus 2c. What happens when we have 2c minus 2c? We have 0 c's. So that leaves us with 2b over 2a, because the c's are going to cross off. The 2's are going to cross off. Those can be reduced, and we're b over a. Since we got b over a again, these are the same. And that's what we did. We showed that they are equal to each other. They are the same simplified fraction. Same rise over run. Okay, for this next step, we're not going to do the calculation. We're going to talk about it. What calculations would be would be needed to show the midpoint of WY is the same as the midpoint of XZ? The midpoint of WY, there's your midpoint, approximately, is going to be the same as the midpoint for XZ. Same midpoint. What are we going to need to do to determine that we have the same midpoint? We will find the midpoint of WY and show that it is the same as the midpoint for XZ. We would need to show the midpoint of WY is the same point as the midpoint of XZ. We should have bars over those. Okay? We would need to show that the midpoint of WY is the same as the midpoint of YZ. That's how we would show that the midpoints are the same. Okay, last example. Here it is a little bit more formal. This looks like a proof. Given we have this triangle, OBC, we know that F is the midpoint of OC, and E is the midpoint of BC. We're going to show that we have two parallel sides. So first we need to figure out what the midpoints are. For us to show that this one is parallel to that one, we have to know what these locations are. So how do we find the location of F? Think about it. If this is the location 0, 0, this is the location of 2p, 0, what's halfway in between? From 0 out to 2p, what's the halfway point? And what's the coordinate of F? So F is going to be p, 0. It's going to be the halfway. So that one was kind of easy to do. We could look to see that it's half of 2p. It's at 1p. So now we're going to have to work a little bit harder about E. Okay, so we'll use our midpoint formula for E. So we have to add the x's together. So point E is going to be 2q plus 2p over 2 and 2r plus 0 over 2. So point E, we can reduce the 2's out of there. As long as we can do it to both sides of the plus, we're allowed to reduce from the denominator. So this becomes q plus p. And this is 2r plus nothing divided by 2. So the 2's are going to be able to cross off, and we just have r. So that is our coordinate for E. Q plus P, comma, R. And R makes sense because we're up 2r to get to B, so we have to be up 1r to be at the halfway point. And that's what a midpoint is. All right, last one. How are we going to show parallel? same slope to show segments are parallel, show the slopes are equal. That's what we need to do. Need to show the slopes are the same. So we can do that. Slope of EF or y minus y. So that's r minus 0. Q plus P minus P. That leaves me with r minus 0, which is r. And Q plus P, take away P. What's that? Q plus P, take away P. The P's are going to cross out, and you're left with just the Q. So there is our slope, R over Q. And our last one, I think I've said that 3 times in a row now. BO, what is the slope of BO? Take the y value first, so 2r minus 0 and 2q minus 0. The zeros disappear, so you have 2r over 2q, and the 2's cross off. We did it. We showed the slopes were the same.